This section, I really only have one new piece of information for you. You know what equilateral is. We've seen it. It's been on our vocab quizzes. Same with isosceles triangles. One thing to add to your isosceles when we get to it. Let's practice some vocab since, I said there's a vocab quiz round. Classify each triangle by the sides. If you have three congruent sides, what is the name for it? Equilateral. Can you spell it correct? And remember, this is on the matching part of your vocab quiz tomorrow. Okay, 2. You've got 2 congruent sides. What do we call that? Isosceles. All right, and number 3. None of the sides are the same. What do we call it? Scaling. Got it. Now, for 4. We are going to need this. This is a throwback to like the first section here. We are going to need this piece of the puzzle here today too. In a triangle, A is 70 degrees, B is 50. What's the measure C? So this is a review for you. All 3 angles should total up to what? 180. So if I have 70 and 50, if I add those together, I'm at 120. How many more degrees do I need to get to 180? 60. And again, we didn't even need a calculator for that. That was just a little bit of mental math there. Let me scroll it down for 5. So in triangle DEF, D equals E, and it says F's 26. What are the measures of D and E? Now you might need your calculator for this. I would do 180 and I deduct that 26 to see how much you have left. That's 154. Now D and E are equal. So you're going to find each of them. What are you going to do to 154? Yeah. Can we divide 154 by 2 in our head? 77. Love a little mental math. Okay. So just to review vocab, like I said, and of course we are going to, for sure today, use this all 3 angles add up to 180 in a triangle, but we know it. So you know what an equilateral and isosceles triangles are. We just have one new thing with isosceles to show you and a little bit of vocab today. So when an isosceles triangle has 2 congruent, there's the first word you got to fill in. You can use the symbol too if you want. Congruent sides. These 2 sides are called the legs. So you can see here on the side, they just give those fancy names called the legs. Okay, well that's really not all that exciting. The angle formed by the legs, of course, is the vertex angle. So that's that very top angle there. And of course the third side is called the base. Now, this is going to be the new piece of the puzzle we're really going to be focused on today. And it's hard to see like this very lightly shaded red area. I don't even know if the shading copied it all on your note packet, but we're going to talk about base angles a lot today. There is what we call the base angle theorem coming at us in a minute. So first up, the base angles, because they might get fancy and like tip the triangle over or something, the base angles are always across from the congruent sides. So just be aware of that. So the base angle theorem, really what it is, if you have 2 congruent sides, your legs, the base angles will also be congruent. There. Okay, so let's fill that in. Base angle theorem. If 2 sides of a triangle are congruent, then the angles opposite are congruent. So again, you've got your congruent sides. So opposite is this angle, opposite of this one. So these guys are congruent. Your base angles are congruent. And you can abbreviate this. We're going to use it in our proof today. Base angle theorem. All right, flip the page, because the converse is on the next page. Just couldn't fit it all on the same page. So converse, if 2 angles of a triangle are congruent, then the sides are congruent. So this is one of those tricky things we have to keep straight in our minds when we write our proofs, whether I'm using this base angle theorem or if I'm using the converse of it. Well, here's the difference. Base angle theorem, you start with congruent sides. The converse, you start with congruent angles. So you have to keep those 2 straight in your mind, whether it's base angle theorem or the converse. And you'll see, we'll practice some here in a minute. All right, take a look at this triangle. Now, this is kind of what I was talking about. They did kind of tip it over, just for the record. If that really bothers you, you can redraw it, but I think we can handle it. I'm actually going to cheat a little bit. I'm going to start with the easy stuff. I'm going to start at the bottom. Name 2 congruent angles. So across from my congruent sides are your congruent angles. So E and F. Name the vertex angle. Well, the vertex angle is going to be the one that would be at the top of the triangle if it stood up correctly, this one at the end, which the letter's off the page there a little bit. And then, of course, the base. So this vertex angle would be at the top. This is our base, which is segment EF, FE, whatever you want to name it. Got it. So any questions on any of the naming or the vocabulary or anything? Too easy, too easy. Okay. No proofs yet. Complete each statement. Now, as always, I can't stress it enough, it's important to try to mark the congruent pieces on the pictures. HG is congruent to HK. So now they want you to identify the congruent angles. Well, of course, the angle straight across. So across from this side's angle G. I started with that one. That was the easiest one to name. And then across from this side is this guy. Now, here's the thing. I can't just say K, because like, ooh, which one are we talking about? I'm going to use the 3 letters. I'm going to call it angle HKG. And you could have that reversed. You could have angle GKH, of course. All right, let's take a look at this. Careful marking these angles. Angle KHJ, so this guy, is congruent to angle KJH, this one. So this time they're giving you the angles. This would be the base angle theorem converse. This is where the converse is. But for us, we need the sides across. Well, it'd be this guy and this guy. So this one I'm going to call it segment HK. HK, there we go. And then the bottom one I'm going to call it KJ. And of course you can have those reversed. So any questions on picking out those congruent pieces? Love it. Oh, hey, we actually get to do math with numbers for once. Find the measure of angle X and Z. Okay, all right. You know all 3 angles add to 180, of course. Now, here is our base angle theorem in play. 2 congruent sides, 2 congruent angles. So if you have 50 degrees for that vertex angle, I'm just going to subtract that, of course, from 180. And now that's how much I have left for those 2 congruent base angles. So how much is each base angle? 65. Just divide it by 2. Got it. Just going to label in the picture. It's nice to do some easy math for once. Any questions on that one? We're cruising. We're cruising. Okay. Now, you know this. You know this. So I've been talking about this ever since we first brought up equilateral. We're going to get a little more specific, though, here today. You guys already know if it's equilateral, sides are the same, it's equiangular. Well, in the next problem, we're going to tie this all together with the fact all 3 angles in a triangle add up to what? All 3 angles in a triangle, what do they add up to? 180. So can you figure out what each congruent angle would be? What's 180 divided by 3? 60. So all 3 congruent sides, equilateral, equiangular. So they're all 60. So we're going to use that today. Any questions on that? Hey, some real numbers again. Here we go. Look at us. So find the values of x and y in the diagram. Now, there's a lot of triangles in this picture here. Doesn't matter you start with x, start with y. I'm kind of looking at the left triangle first. I'm like, ooh, equiangular, so I know all these sides are the same. So I don't need to do any work. What's y? Y equals 4. Because all of these would be the same. Now, next up, I'm looking at where x is. We need x. I see I have my 2 congruent base angles, so of course the sides across from them are congruent. All right. So x plus 1 and 4 are equal. Well, let's just do a little mental math. I don't think we need to do anything else. What's x? 3. Got it. So just practicing that equilateral, equiangular all ties together. Any questions on that one? All right, let's take a look. Do we remember how to calculate perimeter? How do you find perimeter? Add up all the sides. So I first need to figure out how much is each side. Well, equiangular, equilateral. Does it matter which 2 sides I said equal? No, they're all the same. So I'm going to pick what I think looks easiest. I think x plus 13 looks easy. And I think 2x plus 4 seems easy. Pick 2. All right, let's solve this. I'm going to subtract x so we have all our x's on the same side. You probably already have an answer for x. X equals, what do you got? 9. Now, we need the perimeter. So I'm going to plug 9 in and figure out how long, what's the length of a side. Doesn't matter which one of these you plug it in. I don't know, I'm standing here at the right, I'm going to put it in this one. What's 2 times 9? 18 plus 4. So each side's 22. What is your overall final perimeter answer? 66. Good. Add them all together. And I'm going to be fancy and just throw a label of centimeters on that. Got it. Any questions on that guy? And just when you think, dang it, this is easy, I like geometry today. You're still going to think that when we flip the page and do our proof.
Totally.
Love the looks on your faces, everybody. Okay, let's start with the given, shall we? ABC is isosceles. Triangle with base. So much writing. AC. AD is congruent to EC. All right, there's a lot of triangles in this picture, okay? So we have to look super close. Details matter, obviously, at the given. Triangle, A, B, C. So the big overall outside one is isosceles. Key vocab word there, isosceles. How many congruent sides do you have for isosceles? 2. So I'm going to mark those. I'm going to have to put that in the proof. I'll do that in a minute. It also tells us AD, this little guy, is congruent to EC. All right, okay. Now, before I forget, and we get carried away here, remember I marked those 2 single congruent outside sides. I'm going to add that in my proof here. I put those on there. So I have AB, and then my right side I'm going to call it BC. And what was the key vocab word in the given that made me do it? Isosceles. So definition of isosceles. That's what an isosceles is. It's 2 congruent sides. All right, before we get carried away here, all right, let's figure out what shortcut we're going to use, one of our 5 shortcuts, to prove the triangles are congruent. And more specifically, let's look at the picture and figure out what 2 triangles do they want me to prove congruent. So DAB, so this little skinny outside one, okay, all right, and then ECB. So we're trying to prove those skinny outside triangles are congruent, which we're pretty darn close, because I have 2 sets of sides. Well, here we go, my friends. If you have an isosceles triangle, which we do, 2 congruent sides, of course the angles across from them are congruent. That is that base angle theorem. So I'm going to put angle A is congruent to angle C. I put those on. And that is just the plain old boring base angle theorem. You can abbreviate. I'm going to write it out. Now, just to recap, why does it not have the word converse in it? Converse, you start with congruent angles. Just the theorem, you start with the sides. So we're starting with the sides. So just base angle theorem. Hey, and guess what? I can tell you those 2 outside triangles are congruent. By what shortcut? Side angle side. We got it. Fill in your proof line, side angle side. Hey, only a 4-step proof. That wasn't too bad. Side angle side. Yes. All right. Any questions on that one? Are you ready for this fun-filled SAT problem? I feel the enthusiasm. Okay, let's do this. So you gotta have a little bit of number sense for you here. So I'm reading this and I'm like, oh man, if 3x minus y equals 12, what is the value of 8 to the x over 2 to the y? First thing, this is an algebra review. You cannot divide 8 and 2 together because order of operations, exponent becomes before division, and you do not have the same basis. So here's a throwback. Let's see if you remember this. from Algebra 1. Do you remember what to do to the exponents if you have the same base when you divide? Subtract. Because of course you'd have 5 of these, 2, you're left with 3, you subtract. So I want to use that. But here's the thing. I have to get the same bases. Like there I had base x and x. So I'm going to work on this 8 because it seems kind of big, not really. I'm going to leave the bottom. So I'm doing a little mental math. I can rewrite 8 as 2 to some power. Question is what power? 2 to the third. 2 cubed is 8. And you still have also in the exponent x. Now you've got the common bases, just like I have over there in the red. You subtract your exponents. But 3x, y, they're not like terms, so I'm not going to get too carried away. I'm just going to put 3x minus 1. And I'm like, oh, I got the answer. This is easy now. Letter, read it. What's 3x minus y? So it's 2 to the 12. Just throw a 12 in there. Piece of cake, right? Excited for the PSAT in the spring?